Hello, everyone, and welcome back to Lady Scientist Podcast. I'm your host, Jocelyn Pearl, and I have another great interview in store for you guys today. I chat with an associate professor, Dr. Stacey Gorniak from the University of Houston, about her research and her career journey. It's a great conversation, and I can't wait for you to learn from Stacey's experience. Before we jump in, I just want to thank Kendall Investor Relations for supporting this show, and thank you to all of our listeners and subscribers. If you've been enjoying our content so far, please subscribe and leave us a review wherever you listen to podcasts. Today, I welcome Dr. Stacey Gorniak. She's an associate professor at the University of Houston. She studies diseases like diabetic neuropathy and diabetes and uses biomechanics to understand how these different diseases impact men and women and impact their functional independence. And we're going to get into some of the exciting findings from her work today. So welcome, Stacey. Hi.
Hi.
How are you?
I'm good. How are you?
Doing good.
I'm really glad to be here.
Thanks so much for joining. So can you give us a little bit of background on yourself and kind of your path in science and academia?
Yeah, so originally I'm from a small town outside of Erie, Pennsylvania. I went to school originally to be a chemical engineer and ended up in physics as a middle ground between my dad wanted an engineer and I was a little bit more drawn to the sciences. I ended up getting a master's and a PhD in kinesiology with a specialization in biomechanics motor control and some work in statistics. And I have a postdoc in biomedical engineering.
And how did you first become interested in the biomechanics field?
That's a great question because there aren't many of us. I was really interested in medicine, particularly when I was younger. And when I first went to get my bachelor's degree, I was really interested in going into medicine, going to med school. And part of my undergraduate career, we had to either do an internship or research internship within like one of the faculty's labs. And there was an opportunity to do an internship in a children's hospital in a biomechanics lab. And my advisor recommended that I apply for it. And I fell in love with the field from that moment. I just love the blend of both science and clinical environment, and I was just gone from then.
Was that first biomechanics lab like what type of research were you working on? What was it made up of?
So it was at a Shriners Hospital. It was an orthopedic biomechanics lab, primarily to assess movement in children who had cerebral palsy. And so basically assessing their movement patterns prior to surgery to try to basically find which muscles were most impacted by the cerebral palsy and determine which course of treatment would be best for them, whether it be surgical tendon lengthening or continued Botox injections to those muscles.
That seems like extreme interventions to me.
They are.
And I'm going to preface this. I'm very naive to this field, so I'm going to have a lot of silly questions for you along the way. But I'd love to just understand this field more through your eyes and through your experience. So I'm excited to dive into it. And fast forward to your work now. Are you leading a small lab? What's the makeup of your research team? And what's really the focus of your research today?
So right now, I just have 2 graduate students with a third on her way. She had some visa issues. But I have a very large collaborative co-I teams where we bring a lot of different techniques together to try to understand what I would consider a non-traditional movement disorder, which I would consider type 2 diabetes to be. Usually when you're talking about a movement disorder, you're talking about something like stroke or Parkinson's, Huntington's, areas like that. So type 2 diabetes hasn't been explored very well as a movement disorder beyond peripheral neuropathy. And so that's what we're working on right now.
I see. And what are some of the questions around diabetes that your research tries to understand?
So when I started this line of research about 10 years ago, the predominant clinical opinion was that most functional deficits that you see in persons with type 2 diabetes stems from peripheral neuropathy. And I had some evidence based on some things that I saw in the lab during my postdoc that didn't seem to be the case. And so that's where I started about 10 years ago. And within the past about 3 years, we finally have neuroimaging evidence that there are cortical roots of these deficits in persons with type 2 diabetes, specifically in women. We haven't assessed men yet, but that sex differences question is something that's become more and more prevalent in the field of metabolic diseases.
I've chatted with a couple of researchers who are interested in studying, women's reproduction, and they've spoken about how little funding there is comparatively across, all of these different fields. Can you talk about what percentage in your eyes is focused on some of these sex-based differences, and how unique is your, approach?
Right now, the way that type 2 diabetes is assessed and clinically treated is that there are no differences between the sexes. However, we're starting to learn that there are differences, and there's NIH, for example, is becoming more interested in understanding the sex disparities and health outcomes. But we're really just, in some ways, at the tip of understanding what these differences are, because for a long, long time, women were not included in these basic biomedical studies because estrus and the hormone cycles with menstruation were basically considered as making women too variable to study. And so a lot of the work that we've done over the past several decades have only included men. And so, basing like treatment guidelines and clinical care guidelines and diagnosis guidelines on these characteristics of men, it doesn't translate well to women. And that's why we have underdiagnoses for certain disorders, just different presentation symptoms. And it's honestly untangling that is, it's going to be a very big task. And finally, some institutes are really starting to understand that. So the study that we specifically focused on women was funded by the American Heart Association, which has supported pretty well understanding and identifying these deficits in women. They have their Go Red for Women campaign. And I don't know if you know this, but up to 90% of women have a risk factor for cardiovascular disease. It is a major killer of women. And so
one of the largest killers of women, isn't it?
Yes. Yes.
Which is kind of shocking, right?
and that just plays into it.
Yeah.
So I would say
is the funding mechanisms starting to catch up with that need to understand this disparity?
Slowly.
Okay. But there's still a need there. Like, we need to do more. We need to understand this more, right?
Absolutely. And there's been some changes to NIH standards about including women in research and sex as a biological variable. And so they are trying. It's going to take time.
But there are new grants, new, efforts to try to fund this research. That's good to hear. At least things are changing a little bit. So getting back to your lab, because I really want to understand this. I work on the molecular biology side. I'm at the wet bench. I have PCRs and that kind of thing. But your lab uses all of these different types of tools. So can you tell us a little bit about some of the main ways that you collect data? I saw a video online of a treadmill in your lab. So can you tell us about some of these interesting data types that you collect?
Yeah, so we have everything that ranges from treadmills to infrared cameras that you would see, like a lot of video game producers use motion capture. Sometimes we use that motion capture technology to monitor behavior and just how somebody moves in an environment. Sometimes we use miniature force transducer, so basically embedded in devices, so you can see how a person might handle an object in daily life. Sometimes we use iPads, sometimes we use infrared in a different way instead of looking at like the biomechanical aspect where you're just tracking human motion. There are methods in which you can actually use infrared to penetrate tissue and to measure blood flow underneath. That's part of the neuroimaging technique that my lab has been working with. The collaborator we work with is Dr. Luca Polanini, and he's been absolutely fantastic. And just his insights have been actually just really, really incredible for our lab. And he's allowed us his expertise in this area so that we can do things like measure muscle non-invasively, measure brain tissue non-invasively, and better understand what's going on basically underneath the skin.
So when you say measure muscle non-invasively, can you break that down for me a little bit?
So when we're doing that, we're not taking biopsies. What we're actually doing is using technology like if you ever look at your iWatch or a watch, something like that. So those are actually like infrared emitters and detectors. And what's happening is that infrared light is basically going through your skin, and it's being, it depends on what wavelength it is. It's being scattered and then being reflected back through the skin. And techniques like FNIRS, which is what we use, so functional near infrared spectroscopy, it's basically bouncing light off of oxygenated blood and deoxygenated blood and understanding, the concentrations of those within the muscle. When do you see more of one versus the other? There's different, you can use different wavelengths to look at different things. I know some labs are also looking at glycated hemoglobin. So basically like how much hemoglobin has sugar attached to it. So there's a lot of different cool things that you can do with these techniques.
It seems like you could just tap into this wealth of data across actual people, which is kind of unique considering how much of a reliance we have on animal models for, other areas of research. Is it just a ton of data? Like, do you have to have a massive, server and database to hold all of this data?
No. So that was one thing when I first started about 20 years ago, was that, some of the data sets we were collecting were huge. But as computing technologies just advanced, coming across a 1 terabyte drive isn't an issue anymore. I mean, we have, 8 terabytes, and that should get you through a lot. So there are a lot of data sometimes, depending on your sample rates. But I would say technology's really caught up to where we needed it to store large amounts of data.
And then how do you parse that data? Like, do you work with, are you computational, or do you work with computational folks who have to kind of deconvolute all of this video and infrared images? I just am picturing it being like a massive computational problem.
Yeah, no, it's a puzzle. And so we have very powerful software. A lot of us know how to code. So being able to, program, I use MATLAB a lot. Some people use LabVIEW. And we do a lot of data processing to get down to, whatever measure that we're interested in. Sometimes we have to filter data. But that's learning how to program and to deal with raw data is an essential critical skill for an early graduate student in our area.
That's neat. What are there any other kind of essential critical skills that you look for when you're bringing someone on to do this type of work?
So programming is definitely big, and understanding basic math and having a lot of different exposure to different math techniques. Those can be taught, but you also need to have somebody who can interact with patients very well, right? Having that bedside manner, because we do rely on individuals in the community to come in and be our test subjects. And so having computational skills, having soft skills, being an excellent communicator, and being able to explain to somebody what they're going to encounter during a study and being able to answer questions. That's not to somebody, like their mentor, somebody that has a PhD, but to be able to answer it in a realistic way to somebody in the community. Those are skills that somebody might not think about when they're applying to graduate school, but those are actually very, very important skills.
Interesting. That's a really interesting mix of soft skills and technical skills. And I can imagine it takes a certain type of grad student to be able to handle all of that fluently. I had a question for you. So I did a little bit of research in the systems biology space, and we are also kind of adjacent to this personalized medicine industry and interacted with some folks that were much more interested in like physiological readouts. Do you consider a lot of this work to be within that, or is it more, I mean, I'm just curious about the breakdown of the nomenclature here because you're taking neuroimaging, you're taking, all kinds of other types of data from someone as they're moving about in a space. Is that considered physiology?
Physiology, biometrics, things like that. Yes, there have been some attempts in our area to use machine learning algorithms to generate personalized medicine. I would say we're still very early on in that space right now because of the sheer amount of data that you need to use things, different techniques of machine learning. But yeah, a lot of what we do has also been termed as biometric analyses.
I see.
In this space.
And can you contrast or even just share how you think about these types of measurements compared to something more on like a blood panel or metabolomics or, some of these more molecular analyses?
Absolutely. I mean, I think they're complementary. So that's something else that we do in the lab. We do have blood draws, and so we do have a collaborator who will assess those for us. We can do some things point of care, like somebody's A1C, their lipids panel, but some of the, we have somebody who does ELISAs and all of that for us. But getting into that complementary space is an area that I'm currently taking the lab because having more information, I think, will help clarify the mechanistic issues that we're really trying to get to.
That makes sense. Getting more into the nitty-gritty of some of your research findings, you shared a recent publication in neurophotonics. I was hoping you can walk us through some of the key findings from that paper.
So this was the work that was funded by American Heart Association. And the thing that was really interesting about this is that we focused on women, specifically postmenopausal women, and really trying to better understand what the impact of type 2 diabetes is with aging in this population, with the assumption that this should be our most impacted population, our most negatively impacted population. And what we actually found was that when we look at brain activity during tasks that have sensory components like tactile vibration and also motor components, we saw that there were differences in brain activation between the two groups in the motor tasks, but not the sensory tasks. And what was super interesting was that it was the neuroimaging marker was the oxygenated hemoglobin. So the oxygenated blood was different. And that was unexpected in a way that, well, it wasn't. Let me say this. The oxygenated blood showed a difference, but the deoxygenated blood did not show a difference. And there's been disparity in the MRI literature, like the functional neuroimaging literature, because there's been a lot of no results. The difference in the way that we've approached this is using fNIRS versus fMRI. fMRI really can only assess the deoxygenated hemoglobin because there is paramagnetization there. whereas the oxygenated hemoglobin does not have that type of affinity, and so it's largely undetected. So using this different imaging technique, we were able to actually see that the oxygenated blood it was different. The patterns were different in this population. Nobody had shown that before.
Wow.
Yeah. So,
and to clarify, typically in an MRI, the person is not moving. Is that correct?
correct.
But with this FNIRS technology, you're able to actually record information as the person's moving?
Yes.
Fascinating.
Additionally, you can put this on a person in almost any environment. And if they have like a pacemaker or an implant, like a stent or an artificial limb or joint, it's fine. Those are people that you can't put in a scanner. And so if you have any type of cardiovascular implant, that automatically excludes you from some of these prior studies. And so this gives us a more comprehensive view of the true population.
I see. I have a curiosity question for you. So some of my, experience with understanding biomechanical recordings has to do with therapeutics that were developed for instance, patients who were blind, who are now able to like move through a space. And they're kind of interesting, assays or endpoints that are developed specifically to allow these treatments to be evaluated in clinical trials. Have you had any experience, or has your work related in any way to clinical trials or the evaluation of therapeutics?
Not in terms of the work that I'm currently doing. It's much earlier on in the pipeline. When I was doing my postdoc, it was more assessing actual clinical outcomes based on intervention, which helped inform the directions I wanted to go. I would love to get to the therapeutics point at some point, but I'm years from that, unfortunately.
Getting back to your research path, when did you know that you wanted to pursue a career in academic research?
So that was a little less clear. I knew that I wanted to go into this area and get a graduate degree. I wanted to get my PhD, I knew that. But I wasn't so sure if I wanted to go more of an industry route or an academic route when I was in graduate school. And it took a while, but I just loved being in the academic environment. I thought I would really want to be at a soft money institution. And so that's why and also a clinical institution. So I did my postdoctoral fellowship in an institute, a very large clinical institute that ran on soft money. I saw upsides, downsides, and decided that really I wanted to be back at an academic institution. I just loved the variety that I saw day to day in academic life, but also there's just something incredible about being able to choose the path of research that you do. And working with students, I just really loved it.
So you love the kind of freedom aspect of pursuing new questions and answering things that have never been answered.
That, and I do enjoy the teaching aspect.
Oh, right.
Having graduate students, mentoring, I really, really enjoy that aspect also.
Yeah. Do you teach currently like academic courses?
I do. I've taught graduate and undergraduate. Currently, I teach an undergraduate biomechanics class, and I absolutely love it.
And as far as your job search process, what was that like? I assume, how long were you in your postdoc for?
2 years. The timing of my PhD was not great in terms of the academic market. I defended in 2009, which was right after the 2008 crash. And there were not many jobs at all for about 2 to 3 years after. There was a freeze on hiring for most institutions. And then in 2010, 2011, the job started opening up and it was extremely competitive. So there were many applications that year.
Yeah. Can you give us a sense of how many you applied for, how many you interviewed for? You don't have to share that, by the way. I just, it's one of those things not a lot of people talk about. So.
No, I mean, I think that this is an important thing that people should talk about. What are the expectations? What is this truly like? And to be honest, I put out over 20 applications that year. Because maybe in the field total, maybe there had been 5 in the previous 2 years, if that. Mm-hmm. And I didn't even bother with those. So I put out about 20 applications. There were 3 institutions that were interested. And I in-person interviewed at University of Houston, and I felt that it was the right place, that I could get the work that I was interested in done, but also I had never lived in a major city like Houston, and it was a big change. But I really appreciated that change, and I'm glad.
What was the interview process like? Did you have to give a chalk talk? How many days was it? Was it grueling?
In terms of the interview process, so I had done a phone interview with the search committee. This was before the days of Zoom. And after that process, they invited me to Houston. And so I came down for, I believe it was 2 days. And it was very busy. It was very grueling. It was meetings all the time. I gave a research talk to the entire department. I did not give a teaching talk. For whatever reason, they didn't have me give a chalk talk, and I don't know. Some institutions do, some institutions don't.
And how has it been as a PI? What, kind of give us broad strokes, setting up your group and adapting to this life?
There are good days and there are bad days. It's pretty rough the first few years trying to understand the system that you have entered into. There could be challenges at all different levels, whether they're administrative, departmental. There could be different rules in terms of like state legislatures. There's a lot of things that are just intersecting that really your first 3 years, you're just understanding while you're trying to get your lab up and running, learning who to go to for administrative support, and also just the political landscape of the department and the college and the university or whatever institute that you're at. After about 3 years and where you go through your 3rd year review or whatever their mid probation review is, it becomes a lot clearer as to, this is what I need to do. This is where I need to go. What am I not getting done? That being said, it is still very stressful. The last year before you go for tenure, in most cases, is extremely stressful for most people. And then, should things go well with tenure, which is about a year-long process, and planning for tenure, you really need to keep your eye on the ball, I would say, the entire time. And hopefully you have mentors that will help guide you through that process. I would recommend having several mentors that have different points of view, and not necessarily at your own institution, but from other institutions to help guide you through that process. Because really, you need to think about what your career is going to be like generally and just not at a single institution. It is an important thing to think about, right?
Yeah. Can you share any particular breakthrough days, really great memories over the years that just you felt really proud of the field that you had entered into and the work that you've done?
I think the day that I got my first publication as a senior author, to me, that was probably the best feeling, and my first grant on my own.
Can you share, for the listeners who aren't familiar, the importance of having a senior author publication?
Right. So when you're training, typically your mentor or your mentors are considered the senior authors on a manuscript. And in my field, they are the last authors or the senior authors, and they're the ones that get quote unquote the credit for the manuscript because they've guided the research, they've mentored it, they've mentored the actual performance of the research as well as the writing. And they're the ones that basically are bringing you through the space and developing the research. And so when you have your first own manuscript, you're the one that basically has created this project from cradle to grave, and you're responsible for the whole thing. Making sure it gets done correctly, making sure that all the regulatory pieces are there, making sure the data get collected, making sure the manuscripts themselves get written, and then getting through the publication process, which is not easy. And so that day where you get that first manuscript that you did this successfully on your own 2 feet, feels incredible.
Absolutely. I want to touch on the process of publishing in this field because it's something I recently learned, online, that people who aren't familiar with scientific publishing don't necessarily understand what a lengthy process it can be and how many, hoops you have to jump through sometimes just to get a paper out. So can you share what your experience has been like, and maybe, what a bad experience would look like, just for people to get a sense of how long it can really take to get some of this research out into the world?
All right. So best case scenario, the first journal you choose and you submit to. So when you submit, there's multiple documents that they can ask for. So just the submission itself after you write the entire manuscript, I mean, it can take days to just get done. So once you submit it, if things go really well, maybe you'll have a first decision. And when I say first decision, it's when the editor comes back and says either yes or no, or like a straight up yes or no. A straight up yes is very rare. I've only ever had it happen once in my career, and I was surprised when it happened. A no is just a straight up rejection. The journal's not a good fit, or we just, there are too many issues with this manuscript. We don't want to see it in this journal. A revise and resubmit, major revisions, minor revisions is more likely. I would say best case scenario, that would happen in about 4 weeks. I haven't seen that timeline happen quite some time. It's closer to 6 weeks, 8 weeks anymore, especially with the pandemic. It's even longer than that. So in some cases, just hearing back from your first journal, if you don't get a desk reject, for those of you who aren't familiar with the desk reject, that's just where the editor or associate editor takes a look at the title, the abstract, and makes a decision, yes or no, this doesn't fit with the journal. If it's a no, you get that usually within 2 weeks of submission. So you know pretty quickly. If it's not a desk reject, I mean, your entire just first submission could take 2 months. And then you would have to resubmit if you get invited for the revise and resubmit. You could go through a second review. I know some people that have gone through 3 or 4 reviews, and that's just with the first journal. And so it could take anywhere from, I would say, 2 to 3 months to a year if things go well. If you get multiple desk rejects, then you're going to try to at a different journal, and sometimes you're just cracking at it for it can be years.
Yeah,
unfortunately.
What is your publication strategy like with regards to impact factor and efficiency of getting papers out, do you have a particular strategy that you use?
I really just try to go with the best fit with the topic of the paper and where I think the best journal is. And I'll go with that one first. And then usually I'll have like an idea, okay, if that doesn't work, we'll go here or here. I do try to keep in mind not only just, the best fit of the paper, what's reputable, what are people reading, impact factor. It's not so much something I pay a very large amount of attention to, because I haven't published in Science and Nature at this point. Maybe I will someday, maybe I won't. But I'm still doing really, really solid research that is valued in certain journals and certain communities, and communicating that is really important. And just knowing, who to get your science out to is sometimes the most important piece, and not necessarily the impact factor of the journal.
Do you make an effort to communicate the research through conferences, or what are some of the other modes of communication that you rely on?
Conferences, for sure. That's been, for me, probably the best way. However, with the pandemic, that has changed because so many conferences are going virtual. I don't know how many of your followers are in neuroscience, but it was maybe 2 days ago, they pulled out from having an online or a fully in-person conference, and now it's completely online.
Right,
and
the SFN conference.
Mm-hmm. Yeah,
I saw a few tweets around that. I used to attend SFN every year, but it was a big deal, right? Because a lot of people had made travel plans and were traveling from far off places. Is that accurate?
Yeah, I had a student, my most senior student, he was looking forward to going, and he's looking for a postdoc. So he was pretty disappointed.
Wow. And the conference is happening when exactly?
It was supposed to happen about a month from now.
Okay. And they just decided to make it virtual.
It was going to be virtual for 3 days and then in person for 3 days or 4 days. Mm-hmm. But they're only going to do the virtual option now.
Wow. Crazy times. Yeah. I definitely miss conferences. So hopefully they'll be back soon. I wanted to ask you about another paper of yours. You had a paper trying to understand the impact of heart failure on functional independence, which I thought was a really interesting study. And obviously we touched on, cardiac disease impacting so many people. Can you talk about the goal of that study and what some of the findings were?
So great news. You found Hidetaka Hibino's dissertation topic. So that was the student who was looking forward to going to the neuroscience conference this year. So as he's been in my laboratory, he's been very interested in the intersection of sensorimotor function and cognitive impairment. And people might not know this, but individuals with heart failure struggle with cognitive impairment. And he really thought about that and how much that impacts sensorimotor function. And so that paper is actually a review paper that sets up his entire dissertation.
Oh, that's awesome.
Yeah.
And so he's done some of that research now in your lab?
He has piloted a few subjects, and he is getting ready to propose his dissertation here, hopefully by the end of this year. Exciting. So he'll be looking for research. He'll be looking for research subjects for that study very soon.
Awesome. Is there a particular way that people can find out about this study?
So usually I'll probably put something up on Twitter if anybody's interested. We do sometimes advertise through Twitter. Other times I've started using Facebook, actually, Facebook pages for our studies. And so people can contact us directly through Facebook to learn more about the things that we're doing in the laboratory for our various studies.
Nice. Yeah, because we can always link any of these materials as well for folks listening and wanting to participate. I know it's a it's great to get more people involved. And I imagine that the research becomes more robust as you have additional subjects.
Absolutely.
Getting back to kind of your career and your journey from postdoc to associate professor, have there been any particular support systems that you've relied on over the years that you could talk about that might help others going through this process?
So one of the things that I've really appreciated is mentorship by other women in sciences. I was fortunate enough that there was a senior female researcher in my department who really took me under her wing when I first arrived, and she introduced me to other female scientists within Houston, and just that was absolutely invaluable. And then from that, getting connected with certain regional institutions like the Gulf Coast Consortia for Quantitative Biomedical Sciences, that has been an absolute lifesaver also here in Houston. It's just helped with networking, getting a better understanding of the different major institutions, making friends, making excellent connections within the community. I would say that those two were really critical to my success here in Houston.
And do you have any particular advice for women starting down this path or researchers in general?
It's a really big question.
Yeah. I just always like to ask because you never know what people are going to say, and it might help someone. So
one of the things that I've learned, so I'm actually current. So I think the one thing I would say is that mentoring just doesn't stop when you become a faculty member. I mean, I'm still mentored today, and some of the best mentors I've ever had don't come from a background like mine. They don't look like me. They aren't, they're from a completely different population. And so having mentors that have a very different experience can be very invaluable because they can help you see the world in eyes that you've never even thought about. And some of the shared experiences you may have, you just never would have thought of. And so I would say seek out a diverse pool of mentors and don't stop growing. Don't stop challenging yourself because it is a hard road, but you still got to grow.
On that note, how do you hope to grow your lab and your research, and what are some of your dreams for the future?
I would really love to get into just some really, really large studies in terms of but multi-level understanding, right? So like integrated physiology, interleaving not just like molecular things, but understanding how sleep processes impact these things, just really building that collaborator network and having very comprehensive research lines. I think that that's where we're going in science, just really collaborative and comprehensive science. And that's where I want to go. I'm building for that now, and I'm hopeful.
That's awesome. I love that. Sleep is so important too for so many of these disorders that you touched on already, Huntington's disease and Parkinson's and many psychiatric disorders even, it's really tied into how efficiently people are sleeping and able to sleep. And if they can't sleep, that having impacts on, cognitive function and all of these other things. So I think it's such an important area of research. And I think it's admirable to really want to tie all of these different inputs together and understand, maybe even some of these early signals, for instance, with diabetes, or, signals that we didn't necessarily think of ahead of time with regards to cardiac arrest and independence. So I think it's a really exciting area of research, and I think will be illuminating for so many people suffering from these illnesses.
I hope so. Just to create like a small piece towards that.
Yeah, you are. That wraps up my interview with Dr. Stacey Gorniak. Stacey, thank you so much for being on the show. And to all of our listeners, thanks for listening. If you're interested in this field, check out Stacey's links below. And if you're interested in neuroscience, I recommend you check out the episode I did with Dr. Kanika Rajan. It's a really interesting one in the field of neuroscience and artificial intelligence. Thank you again for supporting Lady Scientist Podcast.